transpose, right? Okay. So if A is equal to A transpose, we call A as symmetric matrix. Second condition for this one is for a skew symmetric matrix, a square matrix in which if A equal to minus A dash, we call this A as skew symmetric matrix. Okay, this is a mathematical rule, fine. Here, mathematical rule, fine. What is the consequence of it? Suppose if I take a symmetric matrix, we find that Aij is equal to Aj ma. Please note down this point. Aij is equal to Aj. Friends, please follow this. This is the number one rule, ma, please. The meaning of this is this only, right? A equal to A transpose means what? Aij equal to Aj. That only I am reorganizing for elements. Okay, this is an element. If element in the ith row and jth column will be equal to an element in the jth row and ith column, that's why transpose. Okay, transpose is the meaning of A equal to A transpose. Okay, that is a symmetric matrix. What about the skew symmetric matrix? In the one we need to tell few things now. If I translate this into a matrix, 1, 2, 3, the diagonal elements. Diagonal elements. Pavitra has come. Okay, Dharanya has come. Brilliant. Enna late Pavitra and Dharanya. Right. Okay, doesn't matter. Please come. Okay. Let us take now again. There are 3 elements here, okay? And there are 3 elements down here. This is called upper triangle, this is called upper triangle, and this is called lower triangle, this is called lower triangle, this is called upper triangle, yes. UP, UT and LT, low tension and high tension, HT. We call in the electric sense power, okay, power transmission, we call them as lower tension and high tension. Okay, what does it mean? Low tension and high tension, please, come on. That means high voltage and low voltage. That's called high tension and low tension. Here is upper triangle and lower triangle. Upper triangle and lower triangle. Come on, let me just fix it well. Yeah. Right. The top portion is not visible. Please look at. So you look at this one now. 1, 2, 3 is a diagonal, please. This also diagonal, but this diagonal is called what diagonal? This is called principal diagonal, and this is called secondary diagonal. We take principal diagonal means what? A I I, right? These are called A I I. What does it mean? A11, A12, A22. A33, these are called diagonal elements. We call principal diagonal elements. You don't have this 1, 1, 1, first row, first column, and the sequence in one of them in the diagonal. This is called A13, this is called A31, this is called A21, this is called A12. The reverse one is the same one. That's a principal diagonal. This one the secondary diagonal. This is the principal diagonal. This is PD. And this is called SD. We don't have secondary diagonal, useless for us. The only principal diagonal is called what? Top left and bottom right. Top left and bottom. Friends, here, if you see your symmetric matrix, a square matrix is a symmetric matrix, and this upper triangle elements, please, upper triangle element, this is called A23. The 3 elements, they must be equal to A12 is equal to A21. A12 is equal equal to formula A1 2 is equal to A21. A21 is equal to A12. Anyway, same thing, right? So because this will fall on this. This will fall on this. And this will fall on this. Wow. I hope you are all able to see and understand what I mean, right? Taranya, clear? Yeah, okay. Yes, Pavitra, clear? That means what?
Yes, sir.
If I fold it now, A12 will be equal to this one. Exactly, these two are mirror images now. Mirror image, and I stand before the mirror, you can see my image and I can see my image. Therefore, A12 will appear here, but the same number has to be there. The minus 5 minus 5. That is called symmetric matrix. So let us go for now skew symmetric matrix. Here, friends, here there are two conditions in a symmetric matrix. Number 2, this will imply A equal to minus A transpose will imply few things. First rule is that A11 is equal to A22 is equal to A33, that's equal to 0. That is the beauty of skew symmetric matrix. And then A12 is equal to minus A21. Unlike A12 equal to A21, here A12 equal to minus A21. Because of this minus property, all the diagonal elements become 0 because you cannot have a sign change. Okay, for anyway, whether you understand or not, what is going on because of this A equal to minus A transpose, all the diagonal, that means what? Principal diagonal, first you place all zeros. Then, if I write 1, 2, 3 here, what should be here? Balisna, tell me what should be here, ma?
-1, sir.
Is it -1? Wait, ma, please. What should be here, Pavitra? I think you have able to see. What should be here? -2. Dharanya, what should be here? Arpit?
-3, sir.
Brilliant, sir. See the difference, please. See the difference between the symmetric matrix and skew symmetric matrix. Okay? Friends, is it clear, ma'am? Please write down. Write down, pa, write down. Yes, pa, over. Have you taken this?
Yes, sir.
Right. For my symmetric matrix or definition is given here. See the beauty of this one. A is A transpose is called symmetric matrix. A minus A dash is what called null matrix, correct? 0, right? I transpose A minus A transpose equal to 0 mark. Right? That's and similarly we defined A equal to minus A transpose is for a skew symmetric matrix. A plus A transpose. This is how you can say, ma. Either you say this condition, this implies this only, right? So you can say sometimes this is the condition for skew symmetric matrix, and this is the condition for symmetric matrix. Yes. Okay, please. If you want to say in a different style, this is the symmetric matrix or condition, skew symmetric matrix or condition. Okay, but see the paradox here. See, what is the paradox is that yesterday I told you, right? Any square matrix can be written as sum of symmetric matrix and skew symmetric matrix. Please note down this: any square matrix. Okay. So what is A is my matrix for? A is my square matrix. I'm able to write this my square matrix as sum of symmetric matrix and skew symmetric. A plus A dash. This is one matrix, ma. A minus A transpose or A dash. Okay. Friends, if I combine these two, A dash cancel, you get 2A. Therefore, I should have a half A here and half A here, ma. So this is called A plus A dash. A plus A dash is a symmetric matrix. A minus A dash is a skew symmetric matrix. Confuse about this. Therefore, half into A plus A dash is also symmetric matrix. Half under the scalar quantity, therefore it does not affect the matrix. Matrix will remain. Whatever the property A plus A dash holds, the same property will be remain when you multiply with half. Therefore, half into A plus A dash is symmetric matrix. Skew symmetric matrix. Is this clear, ma? Is this clear?
Yes, sir.
Fine. Okay.
Yes.
So yeah. Please tell me. Is another beautiful story about the symmetric and skew symmetric matrices. So any square matrix can be written as sum of symmetric matrix and skew symmetric matrix. A plus A dash is called symmetric matrix. Now, are you confused about brother? Please, you remember this rule. All these things imply A plus A dash is a symmetric matrix. A minus A dash is a skew symmetric matrix. You take a small example now. 2, 3, 2, 3, 4, 5 years. Okay. What is A dash, ma? 2, 3, 4, 5. Do you all agree, ma? Please, I'm just giving an example for how A plus A dash is a symmetric matrix. Tell me, dears, what is A plus A dash, ma? 2 plus 2, 4. 3 plus 4, 7. 4 plus 3, 7. And 5 plus 5, 10. Okay. Is it right? A12 is equal to A21 or not? See this? Yes or no? A12 is equal to 1. Therefore, it's a symmetric matrix. So A plus A dash is a symmetric matrix. Purida? If you multiply with half, still it will be 4 by 2, 7 by 2, 7 by 2, 10 by 2. 7 by 2, 7 by 2, they both are equal. A12 is always equal to A21 because it is a symmetric matrix. Similarly, please tell me A minus A dash, ma. I know A is given here, A dash is given 2 minus 2 is 0. Wow, look at this. 2 minus 2 is 0. 3 minus 4 is minus 1. 4 minus 3 is 1. And 5 minus 5 is 0. Wow, what is the glittering feature of the skew symmetric matrix? Pavitra, tell me.
0 and 0 are equal.
0 and 0 are diagonal elements, my dear. 6 principal diagonal elements must be zeros. Wow. See this. Clear, Mark? Clear? So,
Yes,
we all
sir.
understood A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. Is it clear, ma? Is it clear?
Yes, sir.
Yes, ma? Yes, any problem, please? No, I don't know whether, can you say this is symmetric matrix? If A is a symmetric matrix, A and A transpose must be same. Okay, therefore, I think I should write. Okay. Yeah, okay. A is a square matrix. What we did is correct, no problem. Right? A is a square matrix. A dash is a this thing. A plus A dash is a symmetric matrix. This is not solo. Okay, please. It's a different concept. If I want to say A is a symmetric matrix, A dash must be equal to A. If I want to say A is a symmetric matrix, I'm not telling that A is symmetric. A is some square matrix. A dash is its transpose. Then A plus A dash is a symmetric matrix. That's a brilliant approach for me. Are you clear, ma? Please, are you clear? This is a beautiful example to say that A plus A dash is a symmetric matrix when A and A dash are the square matrices. See, A minus A dash is a skew symmetric matrix. I hope I am making it clear, right? You should not have any kind of a confusion, ma. Please tell me. So, is it conclusion of symmetric and skew symmetric? Shall I go for the exercise now?
Yes, sir.
Okay. Right. I think can you ask me some doubts from this doubts, Anna? Another question, please, so that we will conclude faster. All question பண்றதுக்கு பதிலா நீங்க சில questions selected questions கேட்கலாம், please. Come on. .3 parama, some selective questions you can ask. You can ask one question, Pavitra. One to 5. If you have a textbook, please look at the textbook and ask me some selective questions so that we can complete faster. Very simple question. Say 1 to 5 mark. See, all of us know what is transpose, correct? First question is about the transpose. A column matrix become a row matrix, okay? Right. Friends, here A is 2 by 3 mark, okay? A is 2 by 3 matrix. And A dash will be what matrix? What is the order of the matrix of A dash matrix? Come on.
3 by 2.
Great, 3 by 2. Okay. So suppose if A is 1, 2, 3 mark column matrix, then what will be A dash mark? Row matrix. That's a beautiful. Okay. Column matrix become a row matrix there. So this is called 3 by 1 and this is called 1 by 3 by transposition. We mean that rows and columns are interchanged. 3 rows became 3 columns. 1 row became, and 1 column has become 1 row. That is called rows and columns are interchanged. Rows and columns are interchanged. That is the first question, yes, first question. Second also on transpose, third also on transpose, fourth also on transpose. Fifth one, A and B are matrices, 2 matrices. Prove that AB whole transpose equal to B dash into A dash. Where A is given as 1 minus 4 and 3 and B is given as minus 1, 2, 1, minus 1, 2, 1. This is a column matrix, this is a row matrix. Friends, we have to prove that this AB whole transpose is after interchanging the order AB becomes B and A, the respective product of the interchange of the transposes. Transposes of the interchanged matrices. Product of the interchanged matrices. That means P and Q are two matrices. PQ dash equal to Q dash and P dash. These are the this product we have to verify, please. Okay, right, friends. So your LHS is AB dash. Therefore, first you find out AB. AB and in the multiplication panel. This is like 3 by 1. This is 1 by 3. Number of columns must be equal to number of rows. Therefore, you get a 3 by 3 matrix. Row with column. 1 into minus 1 is minus. This resulting matrix is 3 by 3. 9 elements should be there in AB formula. 1 into minus 1 is minus 1. That's all over. 1 into 2 is 2. 1 into 1 is 1. That is the first row is clear with the first row. Second row, take minus 4. Minus 4 into minus 1 is 4. Minus 4 into 2 is minus 8. Wow. Next you take 3. 3 into minus 1 is minus 3. Wow. Wow. This is my AB mark. Then AB transpose is what is? AB transpose is minus 1, 2 and 1, 4 minus 8 minus 4, minus 3, 6, 1. Are you able to watch the board clearly?
Yes, sir.
So friends, this is my LHS mark. This is my LHS. Right? Now, RHS lo vandu B dash and A dash mark. Friends, first you find out B dash. B dash and A dash ma multiply pannalam ore vaattinga. What is B dash ma? Minus 1, 2, 1 ma. And what is A dash ma? 1, minus 4, 3 ds. Column matrix became a row matrix. Row matrix became column matrix. Now you multiply ds. This is called 3 by 1 and this is called 1 by 3. So you get a 3 by 3 matrix ma. Please paranga. Minus 1 into 1 is minus 1. Minus 1 into minus 4, minus 3. 2 into 1 is 2. 2 into minus 4 is minus 8. 2 into 3 is 6. 1 into 1 is 1. 1 into minus 4 is minus 4. Wow, wow, wow. So, Parma, this one and this one, you compare, are they equal or not? Tell me. So, AB, this AB transpose mark. This is 1, this is 2 mark. 1 equal to 2 mark. LHS equal to RHS. Yes, this is RHS. This is LHS. They both are same. I hope it is clear. Is it not a beautiful thing to prove that AB dash equal to B dash into A dash mark? If you want, remember for longer time, I give one more analogy here. AB whole inverse is equal to B inverse into A inverse mark. These two follow the same strategy, my dears. Puridappa? This is our next, okay? AB whole inverse equal to B inverse into A inverse. AB transpose is not A transpose into B transpose. If the order is interchangeable, AB becomes BA with the respective transposes. Yes. So it is same AB whole inverse, like AB whole transpose, AB whole inverse is B inverse and A inverse here. So you want to remember for longer time, you have another friend here, inverse friend for transpose. So transpose and inverse are friends with respect to product. So AB transpose is B transpose, A transpose. AB inverse is B inverse into A inverse. Now this is called transpose. This is called inverse, my dears. This is called inverse. Is it clear?
Yes, sir.
Yeah. Sorry. Please say some comments, okay? When you are not seeing the board, you should say, sir, please adjust it, okay? Please. Otherwise, you see, you are losing it, right? Kindly, sometimes I forget. Yeah. Yes. Friends, so I think this is clear, right? So this we have proved it now. The fifth one we have done it. Similarly, ma, please, can you tell me from 6, 7, 8, ma? Whatever question, ma, please. Whatever question, ma, please. Come on. I think it's worth to do seventh question part. Okay. Seventh question part, ma, show that the matrix A. Show that matrix A 1, -1, 5, -1, 2, 1, 5, 1, 3 is a symmetric matrix. Now, show that this matrix is a symmetric matrix. What to do, Pavitra? Tell me. What to do this one? How do I show that this matrix is symmetric matrix? Yes, please. Bhavishna? Yeah, Pavitra,
We
tell
have
me.
to take
Yes, Pa?
the transpose, sir.
Say fully what you have to do transpose. Okay,
We
we will
have to
do
take the
transpose.
transpose and add it, sir.
See, Bhavishna, listen. We are asked to show that A is a symmetric matrix now, please. What is the condition for symmetric matrix, Dharanya?
A plus A does.
Somebody please once again clearly. Bhavishna, can you want to rephrase it? See, ma, there are two things, ma, we are getting confused here. A is one matrix form. We have to show that this is a symmetric matrix. A equal to A transpose and proof on. That's all, ma. Please find out A transpose, and if they both are identical, then we say it's a symmetric. A is a symmetric. If A is A transpose, then A is symmetric matrix. No, please, this is number one. A, we are talking about A. See, A is minus A transpose, then A is skew symmetric matrix. Now, another condition A is any square matrix. A is any square matrix. Then A plus A transpose is a symmetric matrix. It is symmetric matrix. And A minus A transpose whole together is a skew symmetric matrix. This is what the difference between the confusion should not come to us. Okay. Okay. Yes. இப்போ நம்ம அப்படி சொல்லலாம். இது வந்து A is a symmetric matrix ன்னு prove பண்ணோம்னா, see, this is the condition we have to use. So you find its transpose, ma, A transpose you find out, you get a 1 minus 1 5. First row has become first column, second row minus 1 2 1 and 5 1 3 5. Is it right? Both are same? Aha. Oh, pardon. So A is A transpose, therefore A is symmetric matrix proved. That's it. A and A transpose must be identical matrices, therefore A is a symmetric matrix. Puridappa, over? Yes or no?
Yes, sir. Yes, sir.
Yes, ma? Is it okay? Clear? Right. Okay. Done. So this is such a simple rule, ma. Okay. Second question is there. You have to prove that A equal to minus A transpose. Then we say A is a skew symmetric matrices. Okay, I hope it's clear. Right. Coming to, so 7 is done now. Eighth one, paranga. Eighth one is prove that A plus A transpose is a symmetric matrix. A is given. We already done this. I think you can do that. Ninth one, ninth one. Oh, very good. I don't think ninth one is a difficult one. 10th pakalama, 10th pakala. 10th one, express the following matrices as sum of the symmetric and skew symmetric matrices. Given, let us take one question mark, please. Express the following matrices. Express the given matrix as sum of symmetric matrix and skew symmetric matrix. Okay? Yeah. Okay, I'll take second question mark. Second question, they have given A equal to 6 minus 2, 2 minus 2, 3 minus 1, and 2 minus 1, 3. This is some matrix. Okay, A is given. Express the given matrix as sum of symmetric and skew symmetric matrix. Please. So first of all, if A is a matrix given, it is not, no doubt it is a symmetric matrix. No doubt A itself is a symmetric matrix. But any square matrix, he is talking about any square matrix can be written as sum of the symmetric and skew symmetric matrix. Please, friends, here, so you can express this given matrix. So A, we should write it as half of A plus A dash and half of A minus A dash. This is what he is expecting from us. Friends, you find out A dash because there is only A and A dash. Find A dash, same thing you get This is A dash, A and A dash. Because luckily A itself is a symmetric matrix, so A dash is also symmetric matrix. When you add two symmetric matrices, you get a symmetric matrix. Half A is already symmetric and A dash is also symmetric. A plus A dash is nothing but what? 2A, right? This is 2A. Yes or no? A is A dash here. So this becomes 2A and this becomes A equal to A dash, right? Here, A equal to A dash. Therefore, you substitute here, you get a 0 here. So it's nothing but A only. Anyway, you are writing that, so you please write that. What is A plus A dash, please tell me. What is A plus A dash? 12 minus 4, 4. Okay? Next one. Minus 4, 6, minus 2, 4, minus 2 and 6. Plus half into, what is A minus A dash? Null matrix, beautiful null matrix. This is called writing A as, so look at this, is it not symmetric? Is it not skew symmetric? Null matrix is every matrix, okay, skew symmetric as well as, anyway, okay, done, please. So this is called symmetric matrix. This is called skew symmetric. Null matrix is also called as skew symmetric matrix. Null matrix is every matrix, okay? Right. So this is how, see, we know that this solution start number, we know that A is half of A plus A dash plus. And also A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. So there is A dash here. A is given, so find A dash. Then you simply half A plus A dash by the add pannunga. You got this? You subtract pannunga A minus A dash because both are identical. A minus A dash is 0. That's how we wrote it. Clear? One example, another example, when it is not a symmetric matrix, A itself is a symmetric matrix, then doing is no, there's no what say thrill here. But suppose if A is given as some other matrix, then doing is somewhat thrill. The third question part, 7th to 10th or third question part, A is given as 3, 3 minus 1, minus 2, 1, minus 4, minus 5 and 2 mark. Yeah, this is A. That express sum of. So, friends, here this is not a symmetric matrix. They are not equal. A is simply a square matrix. Simply a square matrix. A is not a symmetric matrix, but you are expected to write A as half of A plus A dash plus half of A minus A dash. Here you will definitely will not get null matrix. This is a symmetric matrix. This is a skew symmetric matrix. So you find out A dash, my dears. Okay, you find out A dash. Look at it, 3, 3 minus 1. Okay, 3, 3 minus 1, minus 2, 1. And minus 4, minus 5, 2. Friends, you add A and A dash. A and A add 3 plus 3, 6. 3 minus 2 is 1. Minus 1 minus 4 is minus 5, yes. Minus 2 plus 3 is 1. Minus 2 minus 2 is minus 4. 1 minus 5 is minus 4. Minus 4 minus 1 is minus 5. Minus 5 minus plus 1 is minus 4. And 2 plus 2 is 4 now. What a brilliant thing. 1, 1. Wow. Wow. So it is S7. The half now divided by 1 by 2, 1 by 2. Minus 5. Minus 5 by 2. Wow. Plus half into A minus A dash. Soloma, Dharanya, please tell me what is A minus A dash? First element.
0.
5 plus 3 minus 5, 0, 6. Now this also 0, right? 5 minus 5, Parana, please, Parana. Next, minus 4 plus 1, minus 3, minus 5, minus 1, minus 6, Parana. 5 minus 5, 3, 6. All the diagonal elements are zeros. This is an inverse image mind. 5 minus 5. Clear? Is it clear, ma? This is skew symmetric. So we expressed the given matrix A, which is not symmetric, but we are able to write it as sum of symmetric matrix and skew symmetric matrix. Is clear, ma? No,
Yes,
if
sir.
you want, you can take inside mark. This becomes 6 by 2, this becomes 1 by 2. அப்படி எழுதலாம், okay? இல்லைன்னா இப்படியே விடலாம், ஒன்றும் பிரச்சனை இல்லை, ஓகேவா? Clear? But more steps, you write it 3, 1 by 2, minus 5 by 2 in our complete பண்ணுங்க, ஓகேவா? 0 by 2 is 0, 5 by 2 and 3 by 2, like this you complete now, okay? I hope it's clear, right? So we can go further now, please. That's about the 10th one, okay? 11th and 12th are objective questions. Let us see. You want some copy? You want some time to take? Right. Yes, boss. So let's go for 11th one. What a brilliant question, yes, Paranga. If A and B are symmetric matrices, if A and B are symmetric matrices, both of them are symmetric matrices of same order, means what? If A is 3 by 3, B is also 3 by 3 part. Then AB minus BA. They said symmetric matrix, but we are taking a square now, because if it is square matrix, then only it will obey the symmetric property, dears. Okay, I already told a square matrix is said to be a symmetric matrix. A square matrix is said to be a symmetric matrix if and only if A equals to A transpose. This is the rule, please. You can't get it for all the matrices. Only square matrix will have the feature of symmetric matrix. All square matrices are not symmetric matrices. If they follow the rule of A is A dash, then you will have symmetric property also. Okay, right. Friends, A and B are symmetric matrices. AB minus BA is what matrix they are asking a question. So A, B, C, D options are given. A, skew symmetric matrix. B, symmetric matrix. C, zero matrix. And D, identity matrix. Wow, wow, brilliant. Friends, A and B are symmetric matrices. Let us take 2 by 2, simplest one, to get the verification now. Okay, verification, yes. Friends, sorry, you take a simple matrix now. A is a 2, 3, and 3, 4. Is it symmetric? A 1, 2 is equal. This is a diagonal. Fold upon 3 will fall on 3. They both are identical, yes. And you take B also symmetric matrix. 3 and 4 are the diagonal elements. And whatever you take here, -2, you should take a -2 here also. Yes or no? Now you are holding the symmetric property. Given another, you should respect the given matrix. If A and B are symmetric matrices, you take both of them are same order. 2 by 2 is the simplest model, please. You have to select the right option, please. Come on. Now, what is AB, please? Come on, tell me. What is AB, ma? 2 into 3 is 6. 3 into -2 is -6, ma. This is AB, yes. So 6 minus 6 is 0. Anyway, I want to do separately. 2 into -2 is -4. 3 into 4 is 12, ma, plus 12. Next, second row. Second row, first column will give 2 and 1. A, 2, 1. Get it here. 3 3s are 9 and -8 is 1. -6, 16, 10. So what are you getting, my AB? AB is nothing but 0. What is this, ma? 8. And this is 1 and 10. So this is AB part. What about BA, DS? BA na idinala, idi row ettukonga. I can't write, okay, because I don't want to waste time. First you write B and second you write A. Then that means this is column, this is a row you take, and this is a column you take. Then you get a first element. 3 2s are 6, and minus 2 into 3 is, you should not get confusion, please, 0. Then 3 into 3 is 9, minus 2 into 4 is minus 8 is a 1. Next one, 3 into 3 is 9. So, hey, I am coming here again. See this one. Minus 2 into 2 is, I hope I have done correctly, 9. Okay, brilliant. Next one, minus 2 into 2 is minus 4. And 4 into 3 is 12. So, it becomes 8. Minus 2 into 3 is minus 6, and 16, 10. Now, friends, you subtract AB minus BA. AB minus BA. There is AB here and BA here. 0 minus 0 is 0. 8 minus 1 is 7. Right? And 1 minus 8 is minus 7. And 10 minus 10 is 0. For a skew symmetric matrix, what property is holding back? Diagonal elements are zeros. And the images are inverse images. 7 becomes minus 7 here. So it's called skew symmetric matrix here. So please remember, A and B are symmetric matrix. AB minus BA is a skew symmetric matrix. Is clear, ma?
Yes, sir.
But you see why it is skew symmetric, Anna? AB is having same diagonal as BA. Therefore, diagonal elements will become 0. That's how you could conclude that they form a skew symmetric matrix. If A and B are symmetric matrices of same order, AB minus BA is a skew symmetric matrix. Yes, I hope it's clear, pa.
Yes, sir.
Please make a note, ma. Please make a note. If you wish, please make a note. You have having a freedom to take. You can remember this property also. Okay. If A and B are symmetric matrices of same order, AB minus BA is a skew symmetric matrix. And our property rule if A and B are symmetric matrix same order, then AB minus BA is skew symmetric. Your matrix this matrix is a skew symmetric matrix. That is question number 11. Question number 12 is the simplest one, simplest one. 12th one. A is given as cos alpha minus sin alpha, and cos alpha is. Right. A plus A dash is I. A plus A dash is I if alpha is what? If the value of alpha is A plus A dash become I only when alpha is what? A plus A dash will be an identity matrix. A plus A dash is given as 1 0 0 1 0 0 1 1. This is the meaning of A plus A dash is I, because A is of the second order. A plus A dash also will be second order. Okay, clear? Friends, here you add this A and A dash now. Okay, A dash is nothing but cos alpha, sin alpha, minus sin alpha, cos alpha. Now you write A plus A dash now. A plus A dash na 2 cos alpha is 0, 2 minus 2 sin alpha, sin alpha minus 0, and cos alpha, 2 cos alpha. Yes, Q, sorry, not Q. Now, he said that A plus A dash is I. I means what, yes? I means 1 0. I is nothing but 1 0 0 1 1. So this is equivalent to this one. 2 cos alpha should be 0. If 2 cos alpha is 0, cos alpha will be 0. If cos alpha is 0, alpha is pi by 2. Am I right? Is there option, yes?
No, sir.
Option is not there?
Theta be 60, sir. Then only it'll cancel with 2 and become 1.
Hey, yeah, what the hell I did? Come on, 2 cos alpha is what? First element, right? 2 cos alpha is 1. So cos alpha is 1 by 2. Then what is the 1 by 2 means what? Pi by 3. Yes, brilliant. Array equate. He said A plus A dash is I, right? First element, right? 2 cos alpha is 1 part. Cos alpha is 1 by 2, alpha is cos alpha is 1 by 2, now alpha should be pi by 3, 60 degree notice. Yes. That's right. Brilliant question, Parth. Okay. So that is the end of your 3.3 part. And tomorrow and day after we can have 3.4 is a long one. Okay, properties of you need to express lots of things in the elementary transformations, and immediately now it's followed by test on symmetric and skew symmetric matrices. இப்போவே நான் கொடுக்க போறேன், நீங்க ஆன்சர் பண்ணுங்க. 11th standard is doing very well. They are tuned to this. நான் வந்து கொஞ்சம் மிஸ்மேனேஜ் ஆயிருக்கலாம், கொஞ்சம் முன்னாடி வந்து அப்பா இப்போ கொஞ்சம் டெஸ்ட் வந்து because first time we are using it. அப்படி இப்படி ஆயிருக்கலாம். நீங்க you can use it now. I have added your group also. So now I understood that. So you will get the test now immediately, maybe 10 minutes. So you can start doing it. For 20 minutes test நீங்க பண்ணலாம். 10 questions கொடுக்க போறேன். 10 questions கொடுக்க போறேன். You can take some 20 minutes and complete it. Okay? Right. So tomorrow and day after, Saturday and Sunday, we can have a timing, same timing. Sunday we can decide it, okay? And Saturday we can decide it. But test மட்டும் நீங்க தயவு செய்து இப்போ வருதுமா டெஸ்ட் ஒரு 10 minutes குள்ள உங்களுக்கு you will get it. Please do it. And I can see your marks also now. Everything will be done. Okay, please come on, do it. Don't miss it. Okay. So you will get shortly in 5-10 minutes. You will get the test part. Okay, right? So tomorrow we will be doing our 3.4. Tomorrow, day after, Saturday, Sunday, we will be completing matrices. Okay. Then next week we will complete the determinants. See, third and fourth are how simple. Okay. அங்க வந்து ஒரு எக்ஸசைஸ் பண்றதுக்கு 5-6 கிளாஸ் இருக்கு. ஒரு எக்ஸசைஸ் பண்றது இப்போ ஒரு சாப்டர் முடிக்கிறதுக்கு வந்து we are taking just ஒரு வாரம். Okay, right? So matrices is over ma, and determinants will be started in the next week. Okay, so test will follow. Please get ready. Every day test. I mean every class after you will have a test. Okay, so thank you, all the best. I hope everybody has downloaded the app, I think, right? Because yeah, all of you downloaded the app, right?
Yes, sir.
Yeah, okay, right then. So then I think we will say goodbye now. See you on tomorrow. Okay. Timing is, what timing for tomorrow is best?
So 5 to 6:30.
5 o'clock, sir.
5 to 6:30. Okay, ma. Illana 5:30 to 6:30 போடலாமா? Because I have a class, ma. I have a class at 3 o'clock. 3 to 4:30, ma. I have to come from what is that called? Kill Park. Kill Park na Kelly's la irukuma. Kelly's la na vapas varana, it will take minimum 1 hour more. So 4:45 start panna, 5:45. 5:30 kandipa na I can make it, ma. 5:30 to 6:30 class, 6:30 to or half an hour test. Okay? 20-minute test. So you can close it in 1.5 hours. Okay? So 5:30 to 7 mudikalam. Okay? Illa neenga munnade venona I can do it. Before 3 venona I will do it, because it's not possible for you. You have a school. So 5:30, yes, 5:30 we'll make it. Okay, right, pa? All the best. Thank you. God bless you. And
Thank you, sir.
see you tomorrow
Thank
evening.
you.
5. Thank you.